So good afternoon, class. Good afternoon, class.
Good afternoon.
Good afternoon, ma'am.
Good afternoon.
Yeah, we have to briefly do this because normally I have I'm so busy today. So but I have to briefly do this. Okay. Now, with the last class, we talked about. Okay, well, I gave assignment last time. Oh, this is where the assignment is. Assignment on spiral compound. I'm not seeing it. Okay, this is it. Okay. Okay. Now, there was an observation that was made by one of you, and I'm very much impressed at that observation. It means that you guys are actually reading, right? Okay, so from that observation, I noticed something. And I noticed there was something I forgot to point out, which is actually important if you're talking about naming of spiral compounds. In the last class, when we are talking about naming this, I was talking about a functional group. But I got to understand when that student pointed out something to me, that is Omar. Now that when you have more than one substituent like this, if there is something like double bond, we have to consider double bond. But when there is no double bond, in that compound that has hydroxy group, you consider alphabetical order in your naming. You consider alphabetical order in your naming. Now, meaning that we have to, in that aspect, we have to consider alphabetical order. Remember, in the normal naming of cyclo compound or aliphatic compound or normal nomenclature in chemistry, you have to consider alphabetical order. So bromo in naming must come before chloro. Then, and in that order, alphabetically. So that's what I want to point out. Okay. Now, another thing I also observe that I did not put you across correctly was in naming of ring. A ring that does not have any substituent. In the last class, I was telling you that I'm supposed to name the bigger ring before the smaller ring. Please, the correct way of naming is come from smaller to the bigger, but the bigger ring is going to be like now, if you're naming a compound that does not have substituents, then you have to start from smaller ring to the bigger ring. But if there is a substituent, you have to give the substituent priority in your naming. If there is functional group, you have to give functional group priority in your naming. But you have to follow in order that all the substituents are going to get the minimal number on the ring. Go through it again, and if there's anything you need to talk about, let's talk about it in the next class. Because this spiral compound is important you understand it, because normally in all the exams, you must not miss spiral compounds. They are part of that. This you should be expecting like 1 or 2, it can be more than 2. But nomenclature is very, very important. So I wanted to point at that so that we can continue. Today we're not going to waste so much time. I want to see if I can finish the slide so that we can go back to other thing that is off slide. If there will be a physical class, which I want to find out, because the other ones I wanted to teach them physically. But if there's no physical class, we'll have to know how to optimize maybe whiteboard to make sure you understand what you're talking about. Now, in the last class, we're talking about Bayes' theory. Bayes' theory is going to use so many methods to explain the stability or feasibility of some compound being feasible in terms of whether their synthesis is possible or not possible. Bayer is going to use angle strain, torsional strain, and steric strain, especially in terms of angle strain. We talked about that when you're dealing with angle strain, the Bayer tell you that when any deviation from normal bond angle of 109, the more the deviation, that the more the deviation, the more the strain. And like I said in the last class, the more the strain, the more reactive. Because when you're stressed, you tend to react. So that's what the Bayer is saying. So it means that in terms of reactivity, the higher the strain, the more reactive. Now we are going to also look at the reactions that can occur in Bayers. That should be in the next class. If it's not possible, feasible, I will know how to put up a slide on them. So the reaction that can occur in terms of strain, we're going to talk about. So that in exam, if you're told to explain Bayer's theory in terms of their angle strain, you're going to tell us the deviation from angle and you're going to showcase via a reaction. Tell us a reaction that can occur, why there is a difference in angles in strain, how it's going to affect the reaction. So in that case, cyclopropane can react easily. So if cyclobutane is going to need 50 degrees, cyclopropane at 30 degrees is going to react. And if cyclobutane is going to need, cyclopropane will need something like 100 or 90 higher because of stability. So the more stable, the higher temperature they need for the bond to break, for them to react. So that's what we're talking about in angle strain. Now we'll talk about some of the reactions that can occur is combustion. Combustion is what happens when a compound is exposed to oxygen or exposed to air. And the byproduct is always carbon CO2 and water and heat, because it means that it's an exothermic reaction because heat is liberated to the environment. So that's heat of combustion. Now, we've talked about this slide before in the last class. We're just doing a recap. And you can see how strange cyclopropane is here and cyclobutane. Cyclopropane has the higher strain than cyclobutane. And look at cyclohexane, there's no strain at all. The cyclopentane and cycloheptane has strain. So there's a fluctuation in terms when you compare ring size and strain. But in all the fluctuation, cyclopropane and cyclobutane are the highest because they are the ones that are most strained. So this is what Bayes is saying, that because when angle is strained, when a compound is strained, there is a tendency that they are, in terms of in real life, they might not exist. So some molecules can just assume non-polar conformation so as to minimize the strain. Some of them, they will start having a ring puckering. They'll start shrinking in order to minimize the strain. So that's what he's talking about. He's talking about the larger rings, they have more possible conformation than smaller rings and are more difficult to analyze. So Bayes is telling us that some compounds cannot be synthesized or analyzed because of issue of strain. But at the end of this class, you're going to understand that some of the Bayes' hypotheses are true and some are not true. So that was one of the questions you're going to know about, the success and the failure of Bayes' hypothesis of angle strain. Okay, of strain theory. What are their success and the failure? So we're going to talk about them now. Like I said, ring larger than 3 atoms are not flat. That is what Bayer is talking about. And the nature of larger than 3 atoms are not flat, they are linear. And it's also talking about cyclomolecules can assume non-polar conformation to minimize angle strain and torsional strain by puckering, by the ring shrinking and adjusting so as to minimize. And Bayer is telling us that larger rings have more possible conformation than smaller rings, and they are more difficult to analyze. So these are one of the things Bayer are saying in his own hypothesis of nature of angle strain. So we are going to consider types of strain. We're going to talk about angle strain. Angle strain is talking about expansion or compression of bond angles away from the most stable. Either they are bigger than the stable. Remember, the most stable is the one that conforms to bond sp3 bond angle, right? So when there is a deviation or expansion is higher, compression is lower than the bond angle, it means that it's going to affect it's going to cause strain. So if it's close to the 109, no, it means that it's stable. Any deviation brings about angle strain. Strain is stress. So angle strain is like stress on the angle because the stable angle is 109. So the more you're moving away, increasing or decreasing, you're going to cause the angle to be stressed. That is angle strain. So another one they're talking about is torsional strain. This torsional strain is talking about eclipse of bonds by neighboring atoms. In your 213, you're talking about staggered, eclipse, and all those. That's what they're talking about torsional strain. So when compounds are far away from themselves, they are bound to be strained than when they are far apart. This is what happens when you are in a bus, when everybody is seated on their seat, you're more comfortable. And when you're in a bus like Molue those days, where people are compressed, you're strained because of that eclipsing of bonds. So that's what causes strain. So you're stressed. You just want to at that moment, anybody that touches you, you react because you're stressed already. So, but at that kind of journey, when you come back, you feel like you've gone to one mountain because of stress. Another strain we are going to look at is steric strain. Steric strain is what's caused by repulsive interaction between non-bonding atoms that are close together. Like when there is a presence of bulky group, there is steric strain. That steric strain is going to cause repulsion. When there's a reaction, the reaction cannot occur because of the presence of that bulky group on the compound. So that's the kind of 3 types of strain. So you're expected to know the 3 types of strain. That is angle strain. Should be able to tell us what is angle strain, tell us what is torsional strain, and tell us what is steric strain. So these are the things we're supposed to know as long as we're talking about Bayes' theorem. I've talked about this, what is angle strain. We've talked about this in the class. And then now we're going to talk about torsional strain. In torsional strain, we're going to talk about when we talk about staggered and we're going to talk about eclipse. Staggered is when they are far apart, while eclipse are when they are close together. You can see example of ethane. Now, ethane is made up of 2 carbon. The first carbon and second carbon. If you look at the diagram before the one with ball, that first 0 circle you saw is the first carbon, is the second carbon. The dot at the center is the first carbon. Then the first carbon, remember ethane is CH3. Now, the first carbon has 3 hydrogen. The second carbon has also 3 hydrogen. So when the hydrogens are placed that are not close together, we say they're staggered. Staggered and most stable conformer. But when they rotate at angle about 60 degrees, they're going to form eclipse. They're going to come close together. In this eclipse, the energy, the strain is high because they are close together. Like when 2 people are close together, you can see you start sweating because energy is high. You're liberating, you're releasing energy to the environment. That's why you're sweating. So that's what happened in staggered. But when you're in eclipse, and but when you're in AC environment, even when you're much, the energy will not be as much as the one you're going to experience when you are in eclipse in outside. So staggered is a very stable conformation, while eclipse is a highly strained conformation. So that is, if you ask about example of torsional strain, talk about staggered. Staggered, you've learned about this in your 213. Staggered and eclipse. Staggered is a stable conformer, while eclipse is, when the word eclipse, they are clocked together and are going to have higher energy. Now look at, we are talking about, this is steric strain. If you're talking about steric, it's the effect of bulky group. Look at, we have anti and we have gauge. Now, and look at the anti is more stable than the gauge. Look at the anti. In that anti, you can realize that the methyl group are far apart. So they're not repelling themselves. While in gauge, the methyl group are close together. And that is where we're having the steric strain. So steric strain, when in this context, is the presence of this bulky group. When they are close together, they start repelling themselves. So this repelling nature is what brought about high energy. You can see in the anti, the energy is 0. But look at gosh, the energy is 3.8. So it's having high energy. So that is where we're talking about the effect of steric strain on a compound. So when there is steric, if you're talking about steric strain, you compare anti and gosh. Anti are like staggered. In that case, we are using anti because we are using methyl group. But in staggered, we're using staggered because there is no hydrogen. But both of them, we can also use the same method as said. The anti is as good as staggered because of stability. So there is no repel nature. There is no repelling of the substituents. So you cannot experience anything like repelling. They're not repelling themselves because they're far apart. The only thing that methyl will interact with is hydrogen, the immediate neighboring. But in that gush, the immediate neighboring is methyl, so they will repel, leading to high energy. So that is how to explain steric strain, torsional strain, and angle strain. And I hope we should be able to explain the three if you're told to differentiate between the 3 types of strain as proposed by Bayes. Or what as well, the question can be differentiate between angle or torsional and steric strain. Or the question can also be, there are 3 types of strain. Mention them and list and explain the 3 types of strain. So however the question is coming, you should be able to tackle it because it's a very simple question. So having said that, we're going to talk about strain energies. Now look at the eclipse. When there is hydrogen and hydrogen are eclipsed together, we're going to talk about that what is involved is torsional strain. And when they are hydrogen and methyl, we're also talking about torsional strain. But remember, hydrogen and methyl, if you look at the energy is higher because of the presence of methyl. Then when there is methyl and methyl, we are talking about both torsional and steric strain, and the energy become higher. And when there is methyl and methyl in gauche, we talk about only steric strain, and the energy is not as high as that of eclipse. So in eclipse, you're having, when you talk about methyl coming together, we are having both torsional strain and the steric strain. Steric because they are bringing repelling, torsional because they are eclipsed together and they're going to cause another strain, which is called torsional strain. So a compound can have both torsional and steric strain at the same time. So this is a summary of types of strain. You can see that whenever you're in a class and something is being mentioned all over and all over again, please take note of that. So like I talked about, you should know angle strain, torsional strain, and steric strain. You should be able to distinguish between them. Tell us the example. Please, whatever I'm saying, make sure you go and revise them. Have hands on them. Don't say, this one is simple, I know it. Make sure you write them on the paper and see how you can deal with them. It's very important. It's going to help you in your exams. Like this exam is an elective, like I said, if you're reading elective and you're not planning to get 90, Omar, I'm expecting 95 from you from this exam. 95. In between 90 and 95, anything less than that, you're going to have me to contend with. I hope you're in class. Is Omar in the class?
Yes, ma'am.
Okay. So what I'm expecting from you is minimum of 90% in this course. So that is your target. You know what I mean?
Yes, ma'am.
Yes. So now, in the other class, we're going to go to more details about this, how to employ the Bayes theory, we're going to end up to know the success and failure of Bayes theory. That should be the next class. I would have wanted us to have this class before the season, but I don't know the feasibility because looking at you people now, you guys are already in the mood of festive period. Do we have class next week to Thursday? Do you have class next week, Thursday?
Yes.
Uma,
Yes, ma'am. Yes, ma'am.
are you guys ready for class next week,
Yes, we
Thursday?
do, ma'am. Yes, we are.
That's serious. I'm impressed too. It means that chemistry is becoming interesting. Yes. Okay. So we're going to have class next week, Thursday. So I will look for a means of I'll practice using the whiteboard. So because this time around we're going to talk about the reaction to demonstrate effect of angles. We're going to also talk in details Bayes' theory, the success and the failure of Bayes' theory. Okay, and I think by the time we have 2 classes, we should be able to dust my section of the course so that you go and read and prepare for tests. You know, we are having tests. We are having tests. There is one, is it Ishola or Shola in 300 level? What's your name? Is it Shola or something? There's one Shola name. I know. Eniola, I'm giving you target too. My target I'm giving you is 80%. Eniola Chris. So yes, 80%. I don't any of my students that are doing this course, anybody that have anything less than 75, the person I'm going to seize the person's phone. And at this stage, you cannot. So go and read. It's a very simple course. I would have my prayer for everyone in this class is that at the end, we are going to record. Anybody that failed it, say I failed it because I had B. But it is my desire that all of you have A. So if there's anything you feel like you don't understand, bring that to my notice. So we can be on the same page. So you can enter. That is my prayer for you. Because of the program I have, I'm not going to go further. I just wanted us to interact so there is not. So since I know that we're going to have class next week, Thursday, so I will make out time. After, do you have anything by 2? So we can do 2 to 4 next Thursday. Is it possible?
No, we have class by 2.
Do you have class by 2?
Yes, ma'am.
Okay, we have class by 2. Okay, so we can only do 3 to 4. So now the issue of spiral compound, when I come class next time, I have to go and put a finishing touching on it so that some of the confusion will be cleared. So we can move on to whatever we have. Okay. So and then after tomorrow, in the next class, we might have just 1 class to finish whatever we're having in this section. So you go and read. Read and read. I want somebody that can give me, I want somebody that can just have 98%. That 2% is that I tend not to give the person 100%. So that's what I'm looking for. And I'm expecting you guys to give it to me. Uma, you have a high target too. So
Yes.
ask your question. Ask question. Uma, ask question. Who else? Big people should ask your question.
I have a question on spiral compound.
We'll talk about spiral compound next week. Just ask question on what we did today.
Okay.
We're going to deal on spiral compound as soon as I enter class next on Thursday.
Yes, ma'am. When is the test going to hold?
Don't be afraid. You cannot have tests that give you time to revise. But make sure you're reading along. The test we're going to have is always combo. But remember, your continuous assessment is part of the assignment you're doing on Google Classroom. So don't feel that it does not matter. It matters. So the test is going to have its mark. CA is going to have its mark. So then your exam. So in this course, if I were you, I will make sure that every 1 point matters to me. So I don't take anything for granted. It's better for me to have 90. Now, if they want to add any mark, they are pushing me to 100. Even if do you know why some of these things? Somebody say A is A. A is A, but when you're talking about your transcript, you realize that A is not A. If you want to study abroad and they've seen that all your A's are not just borderline A, that you're having 80, 90, they will know that this student is an exceptional student. Because their own A is different from their own. A there is not 70 is not A for abroad. So that's why whenever you don't read and say, even if na 871, 72, A is A, please make sure you aim at high A if you want to really do something abroad. So make sure you aim higher. For people that are in their finals, Omar and Eniola and others that are final year, I want to implore you, use this your final year to do all the finishing touching. Whenever anyone you want to do it very well. People in 300 level, just have your penultimate shell. Make sure you put in all your best efforts to make sure it works. Your time you're spending in Unilag is worth it. I want to encourage you, and I want you to know that. So all those distractions you are having, as soon as you graduate, like people that graduated, they have excess time to do whatever they want to do. So now the devil is bringing distraction. And that distraction is feeling that, if I miss this, I've missed something. No, this is a distraction that will distract you from the main thing. Get this, whenever you get it and get it very well, 1 month after you've dropped pen as a graduate, you realize that there's no even pen, there's nothing to do again. All those distractions you feel that are attractive, they will not attract you again. All those sleep that are distracting you, when you sleep one day and you're tired of sleeping, you watch movie 1 week and you're tired of watching movie, because they are distraction. Please get focused. Leave your phone. Whenever you're tired of reading, go and watch those topics on YouTube. Equip yourself and do well. So when you leave here, there is competition outside already. So it's people that are very good, not just good. You cannot be competing with a 2-1, and your 2-1 now is a 3.5. Another 2-1 is 4 points, and you want to compete with them. It's not possible if you're talking about having admission outside. So that's why I want you to give it all it takes, okay? And all your effort, God will reward you. So we'll see you in the next class. Thank you very much. Please, there is no
Amen.
question.
Thank you.
Thank